You know when you look up at the night sky and you just see this endless ocean of stars and galaxies, it feels, well, infinite. But what if I told you that everything you can see, everything we've ever found, is just a tiny, tiny fraction of what's actually out there?
So we're going to dive into one of the biggest questions in all of science. Think of this as a cosmic detective story, where we're on the hunt for why the overwhelming majority of our universe is still a complete mystery.
All right, to crack this case, we've got to start with what we do know. The stuff we can actually see and touch. The familiar world.
5%. That's the number. Let that sink in. Just 5%. This is what physicists call ordinary matter. But really, it's just stuff. It's the atoms that make up you, me, this screen you're watching, every planet, every single star. Everything we've ever known is packed into that 5%.
So where did the first hints of that other 95% come from? Well, our first big clue showed up when astronomers noticed something really, really strange about how entire galaxies were moving.
They were looking at these huge, beautiful spiral galaxies, and they asked a pretty simple question. Based on all the stars and gas we can see, what's holding it all together? Turns out, the answer they got made absolutely no sense.
See, the stars on the outer edges of these galaxies were spinning way too fast. I mean, think of a merry-go-round that's just going way out of control. According to our laws of gravity, those stars should have been flung off into the darkness of space. But they weren't. Something else had to be there. Some kind of missing weight, providing a whole lot of extra gravity.
Scientists gave this invisible stuff a name: dark matter. We can't see it, we can't touch it, it doesn't give off light. For all intents and purposes, it's a ghost. The only reason we know it exists is because we can feel its massive gravitational pull on everything we can see. And this invisible cosmic web makes up a whopping 27% of the universe.
But wait, if you do the math, 5% ordinary matter plus 27% dark matter, that only gets us to 32%. We're still missing most of the puzzle. And this second clue, it's even bigger, and frankly, a lot weirder. It's about the expansion of space itself.
For decades, everyone just assumed that the expansion of the universe from the Big Bang must be slowing down, right? I mean, gravity pulls things together. That's what it does. But then, in the late 1990s, observations of distant exploding stars showed something that completely blew everyone's minds. The exact opposite was happening.
It's like a cosmic tug-of-war. For billions of years after the Big Bang, gravity was winning. It was putting the brakes on, and the expansion was slowing down. But then, a few billion years ago, something else kicked in. Some mysterious force started pushing back, and it started winning. The expansion of our universe began to speed up.
And what do you call this mysterious force? Well, scientists came up with another perfectly mysterious name: dark energy. It seems to be a property of space itself, like a kind of anti-gravity that's pushing the fabric of the universe apart, faster and faster every second.
So let's put it all together. Here it is, the complete ingredient list for our universe. A staggering 68% is dark energy, 27% is dark matter, and that leaves just 5% for all the ordinary stuff we know and love. We are living in the tiniest little sliver of reality.
So we have the numbers, but that just makes the mystery deeper. Why can't our best science explain what 95% of everything is? Well, the answer lies in a huge roadblock right at the heart of modern physics. Okay, so we have two incredible theories that explain our universe. On one hand, you have Einstein's general relativity. It perfectly describes all the big stuff: planets, stars, galaxies, gravity. It's amazing. On the other hand, you have quantum mechanics, which describes the incredibly tiny, bizarre world of particles, and it's also amazing. Both work perfectly in their own domains.
But here's the problem. When you try to use them together, like to describe what's inside a black hole or what happened in the first second of the Big Bang, the whole thing just breaks. The math gives you complete nonsense. Our two best rule books for the universe literally contradict each other.
And this conflict has us at a total standstill. We're pretty sure we need a new theory, a theory of everything, that can finally connect the big and the small. And this is why we can't figure out dark matter and dark energy. Our current tools, our current rule books just weren't built to solve this problem.
Now, it would be really easy to look at all this and feel like we're totally lost in the dark. But there's a much more exciting way to see this. It isn't a dead end, it's a doorway.
This huge gap in our knowledge isn't a failure. It's an invitation to be curious. It's the frontier of human exploration, a giant signpost that says, the biggest discoveries are this way.
These unknowns are what gives science its entire purpose. They are the reason we build bigger telescopes, dream up crazier experiments, and ask the biggest questions we can imagine. That 95%, that's where the adventure is.
So, yes, when we look out at the grand cosmic tapestry, it turns out that everything we once thought was the whole picture is just a single, lonely thread.
And that's not terrifying. That's thrilling. It means the universe is so much stranger, richer, and more wonderful than we ever dared to imagine. The greatest adventure is just getting started.